AC circuit containing only a capacitor. So the alternating EMF is equal to E0 sin omega t is applied to the capacitor. So the potential difference across the capacitor is equal to applied EMF E0 sin omega t. V is equal to E0 sin omega t. As we know that in capacitor, the charge Q is equal to capacitance into potential difference. So Q is equal to C as it is. Instead of the potential difference, we apply the equation, we substitute the equation E0 sin omega t. So we need only the current. So what is the current? Current is the rate of flow of charge. So dq by dt. So substitute this Q in this equation. So C E0 sin omega t. So C and E0 will be taken commonly outside because these are all the constant values. E0 is the amplitude of the EMF. C is a capacitance value of the capacitor. So both are constant, we will take outside. So d by dt of sin omega t. So differentiation of sin omega t is a cos omega t into omega. So the omega is comes here. So omega C E0 which is cos omega t. So this term must be equal to amplitude of the current. So we take as a I0. So I is equal to I0 cos omega t. So cos omega t which is equal to sin omega t plus pi by 2. So we will take that I0 is equal to current amplitude, that is E0 by 1 by omega c. Why I will write like this means, so potential by resistance is equal to current. So omega by c can be written as a 1 by omega c. So this term must be equal to resistance parameter. So x lambda naught by, that is not x lambda naught, it is a E0. Amplitude of the EMF divided by the some resistance value is equal to amplitude of the current. So very simple equation. So we have the EMF, applied EMF is equal to E0 sin omega t, and the current value is I is equal to I0 sin omega t plus pi by 2. So it is a 90 degree ahead. So by comparing the EMF value and the output current value, it will be found that the current leads the voltage, or voltage is lagged behind the current by 90 degree. So current is leading the voltage. Current is leading voltage means when the voltage is 0, current is in the one value, some certain positive value. So that is a I0. Then when at 90 degree the current value is maximum, this will become minimum. So the curve will be like this. This is a current equation, current graph. I is equal to I0 cos omega t or sin omega t plus pi by 2. This is the as usual alternating EMF value is equal to E0 sin omega t graph. So this is a maximum peak value of the EMF, that is a E0 EMF amplitude. Then this is the I0, that is a current amplitude. We can draw the phasor diagram for the same capacitor's value like this, because this is the EMF direction. For pure resistors, the current value and the EMF value will be in the same direction. Both are in the same phase. The angle between them is 0. So we are drawing the same line. But for the resistor, that is for resistor. For inductor, this I value is come in the downward direction because 90 degree behind. Here the 90 degree ahead. Ahead means it will be leading, but the voltage will be 90 degree lagging behind the current. So we have to draw the current direction in this direction. So I will show that what is the phasor diagram for inductor. So see that the inductor, the current direction will be in the below direction, negative y axis, because the current lags behind the voltage by 90 degree. But for capacitor, the current value is leads the voltage by 90 degree. So only we have to draw the current direction as a positive y axis direction in this direction, 90 degree ahead. Okay, so I is equal to E0 by 1 by omega c. Already I told that this term must be equal to resistance term. So we can take this resistance as a capacitive reactance. Dear students, I will again recall you, for the resistor we can take the resistance value as a R alone, because we get the EMF amplitude by R. By substituting the Ohm's law equation, E0 by R is equal to I0. But for the inductor, we get that I naught value is equal to E naught by omega L. This omega L is equal to inductive reactance. Omega L is equal to inductive reactance XL. Similarly, in capacitor, this 1 by omega C is equal to capacitive reactance. So X is equal to 1 by omega C. So far we are seeing that capacitor, inductor and resistor separately connected to the AC circuit. In the next video, we are going to see that how we are going to connect all the inductor, capacitor and resistor in series.